Time for our weekly sci-fi segment. Welcome to the Sci-Fi Show on GameSHOUT.
Welcome back to GameSHOUT Radio. This is Sci-Fi Tuesday with your hosts Soulrift and Jadri. Oh yeah!
Woo, yeah! Giggity, 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 giggity.
Oh yeah! We've got a fun show for you guys tonight. We've got a whole bunch of interesting science news. We'll be talking about the new international technology experiment to create a fusion reactor, and the next generation of nuclear power. And we'll even be talking about after the break whether or not the Apollo missions actually took place. Doesn't that sound a lot of fun? Yeah, alright, well Jadri, I saw you coming in with some fun articles today. What have you got for us for science?
Well, I found this neat article right here. They finally managed to get a little advanced with how planes are shaped. You know how pretty much for the past, 40, 50 years, they've always been the same kind of shape with a long tube fuselage?
Yeah, all those planes that we were also used to.
Yeah, well, it looks like right now they're just studying a new, it's a type called the blended wing. Basically, the whole body of the plane is smooth, and inside the fuselage, and it's all just one big piece. And the wings basically, it has no tail to it, so the wings have to kind of adjust with flaps inside, so it bends and lets you do the pitch, the yaw, and the roll. And
whoa,
so
that sounds pretty cool. So it's like a giant flying boomerang or something.
Yeah, almost. It's similar to like a paper airplane. You know how like in the back you'd change the flaps and it would fly different ways?
Oh, yes. Or maybe like a stealth bomber or something.
Yeah, it looks just like a stealth bomber almost. And instead of the engines being underneath the wings, they're actually mounted up on top, above the wing, basically, right in the back of it, just providing all the thrust right from the back.
Cool. So it'd be like a high-end jet engine. So is this for commercial flights, like for passengers, or is it more like a military application?
Well, I'm not really sure yet. It looks like it's basically they're just testing out this wing design. I mean, we really don't know yet how much, what it could be used for. It looks like it might be good for commercial flights, considering it's got the shape of the wing makes it more aerodynamic than normal, and this means it could save like 20% less fuel, so it might be good for hauling cargo. Or it also looks, because the engines are all on top of the wings, that it could be quieter, so it might be good for commercial. It's really up in the air right now. We'll have to see what comes when this has been worked on some more.
That is pretty interesting, because ever since the Concorde was retired, all of us sci-fi and tech buffs have been looking forward to the next great step in aviation. I mean, they've been bringing out these really big new passenger jumbo jets, where you put like a million people in one plane or something, but nothing compared to the class and style of the Concorde. So it would be nice if they had something cool like that.
Yeah, speaking of that, they actually did just, Boeing released their newest model airplane, their 747-8F, I believe is what it was called. And basically this new plane is a bit longer. It's, I think, 5 meters longer, but it seems to be that it's made of better materials now, so it's a little bit lighter, so it can handle more cargo and work basically just the next level up from its older model.
Wow, the 8th incarnation of the 747. That line is just not going away anytime soon, is it?
Well, they're pretty big, and they're built to last.
Well, taking it from cool new airplanes to how about cool new cameras? Blurry snaps could be the thing of the past with the development of a digital camera that can refocus photos after they've been taken. So,
wow.
Yeah, now get this, in an ordinary digital camera, there's little sensors at the back of the lens that record the light levels of each pixel, and then if those light levels are not in focus, then, the image will just appear blurry, and you're out of luck. Well, two guys at Stanford University have figured out how to adjust the light rays after they've reached the camera. You know how they do this? Get this. They inserted a sheet of 90,000 lenses, each just 125 micrometers across, between the camera's main lens and the image sensor. Now, the angle of the light rays, I can't get over this, 90,000 lenses. So, the light rays that strike each of these micro lenses is recorded. There's little sensors in each of these lenses, as well as the amount of light arriving on each ray to the main sensor. And then software can be used to adjust the values and essentially reconstruct the image as if it had been in focus.
That is amazing. I'd hate to see scratches on that lens.
Well, you know, it's just one big outer lens, like a normal camera, and then between the main lens and the actual sensors, there's a layer, a sheet of 90,000 tiny micro lenses. Now, the application of this camera would be absolutely great for taking shots, you know, when you don't really have time to focus, such as action shots, sports games, and sportscasters, and you know, all those closed-circuit television surveillance cameras that always, you know, you see these images of people robbing a bank, and there's just like a totally blurry image of the face. Well, with this software and these cameras, they could, you know, draw in really nice images, even if they don't have time to actually focus or enough light to get a sharp image.
That is pretty amazing. I'm surprised they really haven't come up with something like this sooner.
Well, you know, 90,000 sheets of micro lenses, I'm sure, you know, it wasn't the obvious thought, well, let's put in 90,000 lenses and see how that works. I'm sure it's going to be pretty expensive when it finally comes out, too.
Oh, yeah.
So, going on from cameras to outer space. Now, you might know that our nearest galactic neighbor, in other words, you know, we're in the Milky Way galaxy. Our nearest galactic neighbor is the Andromeda galaxy. Now, it's very difficult to actually measure how far apart these sort of astral bodies really are, you know, not the least because it's difficult to figure out where the edge of a galaxy is when it's, you know, where do you measure the boundary. But we've estimated the distance to the Andromeda galaxy by comparing light phasing of various stars, and we've guessed around 2.2 to 2.9 million light years. So what's really interesting, though, is that Ignacy Ribas of the Catalina Institute for Space Studies in Bellaterra, Spain, and his colleagues have calculated the much more precise distance to the Andromeda galaxy. So by using the light from two binary stars, in other words, two stars that are actually orbiting each other, and because they're orbiting each other, they keep blocking out each other's light. Now, by analyzing the precise light variations between these two stars, this team has been able to calculate the distance of these two stars, and I guess like the rest of the Andromeda galaxy, to 2.52 million light years. So they're still off by about 10,000 light years, you know, give or take, but 2.52 million light years away, as opposed to our previous estimates of between 2.2 and 2.9. So it is certainly a giant leap in precisely mapping the distance of the Andromeda galaxy. And if this technique can be applied to other binary stars in other galaxies, we could probably generate very precise distances to them as well. In turn, by analyzing all these distances, we can create a very nice, very precise map of the galaxy and try to figure out just where everything is and where things are actually going.
Yeah, that would certainly make space travel a lot similar.
Well, we certainly won't be traveling to other galaxies anytime soon, but well, at least we can map them out, right?
Make it easier.
Yeah, and maybe we could use this to find wormholes or something and then travel to them that way.
Yeah, that'd be cool. Now, my next story I've got here is about a new supercomputer that's basically been pushed to an even greater number than it has been before. This is called the Blue Gene/L system, and it ranks #1 in the world's just list of the 500 fastest supercomputers known. And this thing is amazing. This machine itself has more than 130,000 individual processors.
Wow! Wow, that's a lot of processors. And what's the total capacity, the total speed?
This thing has reached a peak speed of 280.6 teraflops, which is 1 teraflop is a trillion calculations in 1 second.
Oh my goodness. So I bet this thing could probably churn out a lot more than 100 frames per second on Doom 3, eh?
We might be pushing 300. You never know. But
wow.
This machine is actually 3 times faster than even the closest rival of the top 500 machines, which is run by IBM, and that's called the Watson Blue Gene.
Okay, yeah.
And that's only got 91 teraflops.
Well, it's still a lot of teraflops, but yeah, I can see how this would be a lot much further in advance of that.
Well, the real neat thing about the Blue Gene /L is that it's very easy to upgrade. I mean, everything is built just so you can pop in new ones whenever you build it. So it's really just a space and energy that's holding it back right now. It looks like it's very modular.
So do you think they could just keep adding more and more and more modules and getting more and more teraflops? I mean, at this point, it's not even so much which computer is the fastest, because you can just keep adding another upgrade and then outdoing your next competitor.
Right. Well, we might see some more innovations where everything can be shrunk down and use less power. So we could see these large machines which look like they take up an entire building, just each of the individual processors, and you could see them shrunk down to a smaller size.
I think what might also be very cool is if they can put these things up in orbit, like a giant satellite system, because we've got a lot more space in space, and then you just keep, putting in another computer, sending it up on on a shuttle, and then connecting it like a giant block of Lego to the other computers, and it just gets bigger and bigger, and eventually it becomes sentient and takes over the world.
Yeah. I, for one, welcome our new robot masters.
Right, well, until we do manage to build some giant computer systems, we'll probably need a lot more power to get them to run. And that brings us to our big interesting story tonight, and that is on the developments in fusion power generation. Now, right now we've already got...
What's that? I said it was worth a shot. Yeah.
Hey guys, thanks for joining us. Right now we've got a lot of nuclear power plants across the world. These are all fission power plants. Now, fission means that you're breaking apart something. What you do is you take enriched uranium, which is a very dense material, very dense element, and then you bombard it with energy, and then this element, nuclear, breaks down on a nuclear scale. It fires off protons and neutrons, and it generates a lot of energy. Now, a lot of times you must have heard of chemical reactions as opposed to nuclear reactions. Chemical reactions like burning fossil fuels, gas in your car, they break down the electromagnetic bonds between molecules in order to generate energy. The fusion, however, produces about 10 million times more energy than chemical bonds, because the strong nuclear forces inside atoms are a lot stronger than the electromagnetic forces that holds atoms together. So, of course, you get a lot more energy when you break down atoms than when you break down molecules in chemical reactions. So the goal has always been to get more energy with less fuel. Now, unfortunately, we haven't really been able to do fusion. We have the fission reactors, and those have proven to actually work out, and there's a lot of nuclear reactors around the world that provide a lot of energy, but we don't have any fusion reactors. We have one fusion reactor, and that's called the sun. And the way this fusion reactor works is that it takes hydrogen, heats it up to about 100 million degrees Celsius, at which point the parts of the atom, the nuclei, the protons, the neutrons, and the electrons all break down, and it becomes a sort of soup called plasma. And then this plasma kind of swims around and bumps into each other and fuses into heavier hydrogen. Sorry, the hydrogen helium. I always get the two mixed up. So anyway, the interesting project is that there was 2 sites picked for the ITER, the experimental hydrogen fusion reactor that they were going to build to test out the possibility of creating viable energy from fusion. One of them in southern France, which won the bid, and that's where the experimental reactor will be built, and one in northern Japan at a site called Rokasho. Now, they haven't abandoned this Rokasho site, and they've decided instead to build sort of a co-project. And this is a project to figure out what materials can be used to actually encase a fusion reactor. So the basic idea of nuclear fusion is simple enough. You heat it up really fast, really hot, in a donut-shaped chamber called a tomahawk. Now this donut shape. Right. How did I mix that up? Tokamak, thank you for correcting me there. Yes.
Yeah, no problem.
Now, I should know that. Didn't they have that in Alpha Centauri or something?
Yep.
Well, much of the energy in the tokamak, the problem here is that you're creating what you do is you put in 2 heavy isotopes of hydrogen. You put in deuterium, which has 1 proton and 1 neutron, and tritium, which has 1 proton and 2 neutrons. So these are sort of heavy isotopes because they've got a lot of extra neutrons. And then when they form into helium, which has 2 protons, 2 neutrons, you get 1 neutron left over, and this thing fires off with 10 million volts of energy. So I mean, this one atomic particle will probably fuel a city for like, well, a couple minutes, I don't know, but you're obviously doing a lot more than one of these particles at a time. You're firing off millions of these particles, each of which are fueled with millions and millions of volts of energy. So what happens is these neutrons fire off from the central circular area, and they impact on the casing and essentially slow down as they reach this lithium core and release their energy as heat, which is then run into water, and then the water runs a turbine. So that's like what a standard nuclear fission reactor works like. That's why they have those big smokestacks. It's not smoke, they're just getting rid of water and helium. Well, these fusion reactors, one of the big concerns they have is that they've never really done any experiments with these sort of these materials. They'll be struck with so many atoms at such a large amount of energy that every single atom in the wall of the reactor will be knocked out of position around 30 times a year. So most of the atoms will simply spring back into place, but some won't. So that'll slowly fill the material of the wall with faults, which could turn into cracks and eventually, into leaks, which would definitely be a bad thing. And this is what happened in British reactors. They had to shut down a lot of their nuclear reactors. You might have heard about this in the news because there were cracks forming in the containment units, and that's because they're being struck with really high-powered energy. Now, there's really no place to actually test materials to see if they would be good fusion containers. First of all, because we haven't really created fusion in a controlled reaction. I mean, we have fusion bombs, but there's certainly no way of having a contained reaction for 30 years and testing if these materials will hold up to this. So what they're going to do is create, in parallel with the fusion reaction site in southern France, a test site in northern Japan, which will simply test out different materials. It'll blast them for long periods of times with beams of neutrons, and then they'll be able to discover whether steel or other materials will be able to withstand the conditions inside the fusion power plant, or if they'll just simply crumble away. So that's really the future of fusion. We won't be seeing any commercial or viable fusion plants to actually power the energy in our homes anytime soon. They still have to build the ITER and this materials testing plant and these studies probably won't begin until at least 2015, so another 10 years from now. After that, they have to build a demonstration reactor that can actually show that, you know, fusion energy is viable to actually power houses and run cities, and that probably won't go into operation well until after 2030, and even then they'll have to start designing commercial plants to be run, and that won't happen until almost 2050. So some of us might still be around to see the day that fusion plants power the Earth, but it's not going to be around the corner, and it probably won't be here in time to save us from the destruction of the world at the hands of the end of our fossil fuel reserves. Well, you know, we've got to take a quick break, but when we come back, we're going to be talking about whether or not the Apollo missions actually happened. Make sure to stay tuned right here on Sci-Fi Tuesday on GameSHOUT Radio. We'll be back right after this.
GamesNet.net is back, and with some announcements about their new IRC services.
Do not be alarmed if you hear anything unusual.
GamesNet was the first IRC network for gamers since 1996. Forget about those other nonsense IRC networks such as QuakeNet or coffee drinkers such as GameSurge. Join the first IRC network for gamers since 1996. GamesNet.net. Ooh, I love it! GamesNet.net.
Are you looking for a stable game server hosting company? Well, BFG Servers has been in business since 2001. Looking for a game server hosting company with real credibility? Well, BFG Servers is a premier provider of internet gaming, voice, and web hosting services. Are you looking for a responsive, knowledgeable technical support? Well, BFG Servers generally responds to account holder technical issues within 1 hour. BFGServers.com, when size does matter.
Welcome back to GameSHOUT Radio. This is Sci-Fi Tuesday with Soulrift and Jadri. And, oh yes. Now, actually, I had an awkward event happen to me today. I was planning for the show, and then Andy comes running into my office, and he's like, "Hey, check this out! Check this out! You know, the Apollo missions never happened." And you know, so I was a bit dubious, and I go and I check out this website. Andy, you want to tell us what you saw there?
I knew you were going to try to wheel me in here. Actually, I've seen a lot of sites and photos about the so-called fake moon landing of the Apollo mission, and I've read sites where it was a conspiracy because the United States wanted to show Russia that they were 20 years ahead of technology, just to kind of threaten them since there was a Cold War going on. But when I went to this website, it opens up with a small movie with this lady talking about the distance between the Earth and the Moon, and she goes into all these different theories of how much thruster power you would need to leave the Earth to go to the Moon. And you know, it kind of made sense because they also said that, you know, here we got the space shuttle that supposedly is farther and much more advanced, and yet it's only traveled maybe 4 inches into space compared to this distance between the Earth and the Moon. And technology-wise, they don't think that back in 1969 through 1973 that it was really possible to reach the moon. It's I forgot the miles that she said, but you know, how was this little spacecraft supposed to survive on batteries to get there and back with air conditioning and everything else? So they believe that the whole thing was a setup, that it didn't happen. It was they do believe that the astronauts went into space but never went to the moon. They just hovered over the Earth.
Well, you know, I've got a very easy counter example to you know, as far as the one where, you know, if they've gone to the moon in the 70s and the 60s, why haven't we gone back? Well, Andy, didn't you go to LA for E3?
Yeah, I went there.
And why haven't you gone back to LA since then?
I haven't gone back because I'm just too busy.
Right, well, and also it's kind of expensive, right?
Yeah, it's expensive for to go to LA. Yeah,
and there's not really that much to see there.
No, just a few palm trees and stuff, like we have in Florida.
Yeah, exactly. Now, see, that's exactly why we haven't gone back to the moon. The reason isn't because we can't. The reason is because it's really expensive. There's really not that much to see there, and, we're really busy doing other stuff. And that's why we haven't gone back. It's not because we can't go back. It's because we don't want to go back. So,
well, the only thing I disbelieve about any theory about it being a hoax, the moon landing, is how can you take these human beings that have been there and back, and I mean, wouldn't they mentally break down if the whole thing was a lie? Wouldn't they mentally break down and give up and say, yeah, it never happened?
Yeah, exactly. I mean, there's so many people involved with these space programs. There's all, the astronauts that actually went there, but hundreds of support crew that worked in the space station, worked to build the space ship, worked in the launch facilities, that had so many roles to play in all this, and none of them have come forward and made this incredible confession that the whole thing is a hoax. And it's just really, really implausible that every single one of these people were able to play along with this hoax for this period of time.
Yeah, I can understand the UFO thing, but I'm kind of iffy on the whole subject because, yeah, the hoax believers, they bring out a lot of good stuff and a lot of things, and it makes a lot of sense. And then you look on the human side of the whole thing, and it's like, these men that are old now, I mean, by now they would have mentally went crazy and broke down if they were lying to the entire nation.
Yeah. And also, I remember in that little movie I saw, they were giving you some numbers on thrust and fuel and the amount of energy it would take to actually take a ship and bring it all the way to the moon. And they made a huge error in their calculations, and that is that they're calculating enough fuel to travel to the moon and then doubling it to come back to Earth. And now that's completely off. Now, first of all, the only time you need a significant amount of fuel is to get from the surface of the Earth into orbit around Earth. Like if you look at the space shuttle, it carries those big fuel tanks and booster rockets, and they drop those off as they go up into space, right?
Right.
Yeah.
Right. Now, the same thing would happen with the Saturn V rocket. This thing actually breaks off segments as it gets up, different stages until it gets into orbit, and then a couple more stages as it gives an initial thrust towards the moon. But once it's going, it doesn't need any more fuel because there's no friction in space to slow the ship down. Once it's going at a certain speed, it'll keep going at that speed, forever. And that's why we've sent little tiny satellites like the Voyager 1 and Voyager 2 all the way out of our solar system on tiny little bits of fuel, just because they've had 30-40 years to glide through space, and they don't slow down as they go. So
I think this movie, by the way, they have a few on sale, and it's kind of funny when one astronaut is kicking the guy out of his house. Did you see that one?
I didn't manage to see all these videos,
yeah,
but we'll post up the link.
Get out of my house.
Yeah, we'll post them up on the forums, but that's all the time we've got for this Sci-Fi Tuesday. Be sure to join us next week.
This is GameSHOUT Radio, the #1 talk game station in the world. Visit GameSHOUT.com for more info. GameSHOUT.